the last part of this workshop, that it's a panel discussion. For that, let me please share the screen. Yeah, so as my colleague Elias mentioned at the beginning of this workshop, the focus is on the professional career space of quantum computing, especially for the next generation of quantum computing scientists and engineers, highlighting the challenges, and we would like to highlight, the challenges and opportunities from a gender perspective, with the aim to inspire these early career researchers and students within the quantum computing community. Therefore, we would like, as I say, to culminate this workshop with a panel discussion titled "The Next Generation of Quantum Computing from a Scientific, Educational, and Professional Career Perspective." We'll have as a panelist the three speakers that we have today: Sofia Vallercosa from CERN, Nithya Sri from SheQuantum, and Marta Pita from QTech. As we mentioned at the beginning, Erika, who was the fourth speaker and panelist, couldn't join today because of a March of Force event, and so we will have three panelists. So in order to let's say, to start the discussion, to open the discussion, I would like to pose 3 questions from the 3, let's say, pillars of the 3 dimensions of a career in quantum computing. The first one is from the education perspective. As you know, so there are already some programs on quantum computing, but there are not so many, they are not fully stable and solid, because this is an emerging field of research and therefore also an emerging topic for education. And we can say that we are now in a transitional momentum in quantum education. So therefore, the first question that I would like you to, let's say, to reflect on is like, what do you think that is the path to follow for people, for students that would like to pursue a career in quantum computing? On the other hand, also, I think it's clear that quantum computing is a multidisciplinary field of research, and that implies, let's say, or requires from different kind of expertise, from physics to computer science to computer engineering and electrical engineering. And therefore, I would like to know your opinion or how to deal with this intrinsic multidisciplinarity of quantum computing and these early stages of the career. The other question is related more to research. As you know, there are plenty of challenges that we need to tackle in order to develop the fault-tolerant and scalable quantum computer. So in that sense, we would like you to reflect in which is your prospect in the topics that you think that will be more fruitful in the next 5 to 10 years. And, or in other words, what will be your advice for a scientific topic for someone who would like a professional career in quantum computing? And the third question is related with the central, let's say, the central theme of this workshop, that is about inspiring this new generation of quantum scientists as researchers. So, and the question is like, what can we do as professionals and also early stage researchers as a PhD to inspire this new generation, especially from this gender perspective that Nithya was already mentioning in her talk. So please, I will open then the floor to the panelists and to the speakers that you can express, let's say, your position on this and these questions that I are posed. You can just touch on some of them and then we will continue the discussion. So please, who would like to start?
I can start, maybe. That's
okay,
fine.
Maybe Marta, please. Okay, thank you very much.
Yeah, so about, I was thinking about the first topic here about what's the path to follow for a person who wants to pursue a career in quantum computing. And I actually find that something that's quite cool about quantum computing is that there is no pre-established path. So it's related to the interdisciplinary of the field. So that makes people in the field totally free to focus and do what they like the most. So you can arrive to work in quantum computing from a lot of different backgrounds, and you already know before starting, if you work in this, that there are going to be lots of aspects of quantum computing that you are not an expert in, and that's going to happen independently of what background you come from. So that's something that seems a bit bad initially because you're not going to be able to be an expert in everything. This is also something that has huge advantages in that, yeah, you can choose among the different in any part of quantum computing that that you like more. And that's also related to the second question, actually. Sounds from the, well, at least from my point of view, I'm more specialized in the experimental part of it. Right now, there are all these different platforms, healthy competing against each other. And it doesn't seem that in 5 years, there's going to be clearly a winning one. So this also offers researchers, especially experimentalists, the possibility of working on a lot of different options. And I'm pretty sure that all of them will advance in the coming 5 to 10 years. And there's going to be a lot of progress in all of them. So one can choose someone working on qubits that are much more advanced now. So it's more sort of engineering work. But for people who are more interested in fundamental physics, which is also my case, or in studying the fundamental phenomena of quantum mechanics, there's also the option of trying to do research on more fundamental qubits that are still starting. So this, this gives a lot of options to people. And about the last question, inspiring new generation, I think that what we can do is just tell about how interesting this topic is and just do a lot of outreach to inspire new people, because it's definitely something that's very interesting for almost anyone, because it has a lot of aspects of almost everything. So I think that, yeah, just showing and telling people how interesting the topic is and how many ways of participating in it there are, I think it's the best that can be done right now to attract more people. Mm-hmm.
Okay, thank you, Marta. I would like to emphasize two things of what you say. The first one is that very interesting indeed that there is no like established path to work on quantum computing, right? It's completely, let's say, it's more open than in other areas that gives you more flexibility, right? But sometimes also for people who are not there, who want to start a career in quantum computing, maybe they might be a bit more lost, right? Because they don't know exactly what to do to pursue this career on quantum computing. And it's also related to the multidisciplinarity of this field. And indeed, regarding the topic, so that might be more fruitful, it's true that now we are exploring all these quantum technologies and we don't know which will be the winner one, right? And therefore also gives you like more choices, but yeah, but still there is an uncertainty there too. Okay.
Yes.
Yeah.
Yes.
Okay. Yeah. Thanks. Maybe we can move now to.
I can take over.
Okay. Yeah. Please go ahead. Thank you very much.
Yeah, because I really like I like Marta your answer. I think the first thing you said. So the fact that at the education level, at the research level, everybody should always, first of all, choose according to what they like best, because they're going to spend a huge amount of time and effort. So that is absolutely the number one criterion that needs to be taken. Apart from that, I think it's also true that the multidisciplinarity makes training more complex, but at the same time, again, it's something good. It's something that should be exploited. So as long as we keep our flexibility, our will to change, to learn over time, to learn new things, that is not going to be a problem for me. That said, and maybe I'm more old-fashioned here. I guess I'm one of the oldest in this workshop. I would say you have to study the basics. Okay, you need to study quantum field theory. You need to study mathematics. You need to spend a lot of time making sure you understand the basic concepts that are needed. Because once you do that, and if you keep up your enthusiasm and your your will to learn, then you can build on top of that. So that is something that should not be underestimated. I have the impression that as technology advances and some fields become very specialized, there is the tendency of teaching details of, of neglecting a little bit of, the common knowledge, the basic concepts that are needed to build, on top. So, and these are the foundations. So I really, it might be like a approach that's taken from a little bit too far away, but I think it pays over the long term. So my I would say suggestion as far as education is concerned is definitely make sure you invest on the basics, because everything else you can build on top of that. Concerning the second part, again, the second question, that's also like my personal view, and it's probably related to the way I approach this field. I think what's really interesting is making quantum computing part of our research, our life, of the way problems are solved. And this requires a big change in the way we approach the problems, in the way we define them. So for me, one of the most important things in the next few years is really trying to look for a way of solving realistic problems. Okay, because this way we will be able to show how useful quantum computing is, and we will be able more easily to actually communicate to people, because we will be able to show them what you can do with this kind of technologies. They will relate. Okay, so this is also something that it's over the long term is useful for improving interest. Okay, because we show quantum computing within an application, we show it within society, we show it within science or industrial problems. So for me, everything that has to do with adjusting our, if we're talking about the algorithmic part, okay, because I'm more on the software side. So everything that has to do with tuning and adjusting our algorithms to get the best out of the hardware we will have access to in the next few years, it's very, very important. Okay, and the way we introduce quantum computing into the computing model, the classical world that we have today, it's also very important, because it will make it accessible. Okay, so those are sometimes considered some sort of side topics with respect to the pure research on quantum computing, but I think they are very, very, very relevant. The other thing that's connected is everything that has to do with co-development. I think at some point it will be very important to take, again, go back to the practical application, to take into account a problem, the algorithm that we want to use to solve this problem, and the optimization of the hardware for that. And these things are really, can be very much related. And when we make them, then we usually achieve better results. So for me, this is another aspect that will be very important in the future. The last thing is about inspiring new generation. This is a hard topic, right? It's what we all try to do with events like this. I very much enjoy trying to give talks or lectures that are more, outreach kind of talk. I think inspiring new generation requires starting very early, already in school. And this is especially true for everything that is related with gender. I think if we arrive at university, it might already be too late. There is then, of course, all the discussion about, female researchers that need to, that leave the field at some point because of, complexity of everything that's related with life, right? So there's also, of course, that part. But what I think maybe it's because I have a daughter who's in school, and so what I really feel very important is attention to how girls learn STEM in school. So this is key.
Okay, thank you, Sophia. If I may summarize your points, so to say, and I completely agree that we need in order to start, let's say, to start in quantum, you need to study the basics of quantum, right? And then to build on top of that. But sometimes I will say that here the difficult part is, of course, there are some basics that are common to everyone, but how far you should go in those basics, right? Because me, for instance, as an engineer, I need to know, let's say, the basics of quantum computing, but I don't need to know the nitty-gritty details, maybe, or some physics or whatever, because first, sometimes I don't understand, to be honest. That's the first thing, right? It takes me like 1 week or 1 month just to understand some context. And the other point is, at some point, you have to draw the line, right? How much do I need? For sure, I need the basics. How much do I need to know in order to build up on that knowledge, right? So that's a tricky part there. On the other hand, in the second point, you mentioned that you are, let's say, in the other side, right, of the what we call full stack, on the top layers, right? And indeed, it's now timely to look for applications and to look for practical applications that we will run in the future, and that will be advantageous to run in a quantum computer, right? And of course, this co-development that you mentioned between the higher layers of the stack and the lower layers of the stack, right? This co-design between them. Okay, thank you. Let's move then to the next panelist.
All right. Yes.
Yes.
So, addressing the first question, I do agree with both my co-panelists that there is no predefined path that anybody can take to pursue quantum computing. So if you see whether there's an undergraduate degree in quantum computing, there's one coming up, I believe, in University of Chicago. But I don't think there are many other opportunities at the undergraduate level to, pursue a formal education. So I think it's more about us putting us outside there, and outside our comfort zone, trying to learn these skills. And secondly, I do agree with Sophia when she said that children should be taught quantum computing. It's very important to catch them young. And, we subconsciously are learning quantum computing in schools as well, because there's some quantum physics that we learn. There is some, we learn about matrices, which is linear algebra. We learn about some quantum chemistry. And, we without knowing, are actually going through the paths towards quantum computing. So it's very important that you learn the basics, as Sophia said very rightly. It's very important to be strong in your mathematics or your engineering or your physics. So that is what I would like to say about the first question. Second question, I have a very interesting take on this. I think it'll be different from many others about the topic that will be fruitful. I think we are in the stage where ARPANET was when they were creating the internet for the classical computers. So I think one of the most prospective subfields of quantum computing will be quantum networks and quantum communication. So in the next decade, when we do have a quantum computer, how are we going to be able to connect them and use them for communication? And this is something that's being done extensively by Delft from scratch, and it's this very exciting research. And I feel that that is one of the most prospective topics in quantum computing. And when you ask me what is the scientific topic that somebody should pursue, I would say that it's up to their interest, firstly. If you like physics, go ahead, learn physics. And it's if you like computer science, learn algorithms. But it's always important to go out of your major to be able to understand some concepts that you need to apply to your field to be able to contribute to quantum computing. And lastly, inspiring. This is a very, very important question, and especially when you talk about gender representation, because what we should do here is to communicate effectively to people through outreach programs that quantum computing is not difficult. Firstly, because there's this apprehension towards quantum computing that, hey, okay, this is a very difficult subject. I'm not going to be able to understand this. This is highly non-intuitive. So we need to address that. We need to tell people that, okay, it might be a little tough, but there are, there are people who will help you out, who will mentor you, especially women who are in quantum computing, who are doing research. They're very, very helpful when you approach them. I think you should network with people in the field. And that is how you grow, and that is how you become the next generation of quantum scientists. So with that being said, I think, programs like She Quantum as well contribute to this. That's exactly what our objective is, to inspire the next generation, to create the next generation of quantum scientists. So I think people should really put themselves out of their comfort zones, try to learn, even if they're at the undergraduate level or even at the high school level. I think you should go out and learn things from platforms like She Quantum, or there are many other platforms as well for learning. So I think that's what I would like to say.
Okay, thank you, Ms. Yashri. So just something that you both mentioned, you and Sophia, it's indeed that we should start with this quantum education from the very, let's say, with very young people, not only at the university level, but from the school, right? And in that sense, I think that there are already like some outreach activities that try to educate and offer some courses on quantum computing to high school students. Something that was not mentioned yet, and maybe it might be interesting for our audience, is like how do you like say how do you arrive to be a quantum scientist or a quantum researcher? So what did you study before? What is your, let's say, your path to arrive there, right? So maybe you can share your experience with them, because that might be also useful and valuable for the audience.
Yeah, absolutely. So I'm from a background of computer science, and I would like to say here that you do not need to be even from you do not need to have a background in STEM itself. You can be from from economics, or you can be from finance, and you can still be able to upskill by learning algorithms or optimization problems and be able to contribute to this field. So when you ask me about the kind of path informal education that they can take, right now, there are very less programs in undergraduate level, like I mentioned. One is University of Chicago that you can explore. I think their program starts this fall. And when you see, there are, when I was talking to Dr. Dean, who is the VP of Research at University of Waterloo, she was telling me that there are very interesting programs specific to quantum information and quantum computing, wherein they're looking for more women candidates to be able to participate in it. And that's why we are also looking at partnering with them. They're very keen on that. And I think it's very important to explore these kind of opportunities, to go out there and see what are the opportunities that are available. And if you cannot do that, there are organizations like She Quantum that can help you. So please reach out to us. I would say that. Yeah.
Okay, thank you, Nisasri. Sophia or Marta, would you like to share your experience with the audience, please?
Go ahead.
Yeah, sure. Okay. So well, I come from a very different background. So when I said that I think people should be flexible and ready to keep learning throughout their career, it's because it's something that I apply to myself. So I'm a physicist, and I've been an experimental physicist for a long time. So classical computing entirely. Then I switched to AI. So I started to got passionate about that. It's really great field. And at some point, quantum computing, and it's not easy, okay? Because the downside of switching and evolving this way, of course, you get to see many different interesting things, but it's also you're always making an effort and trying to reach the level that's needed to do research at that time. So it is true, I think, that you can arrive and do this starting from whatever starting point, okay? So it's not. It shouldn't be considered an obstacle, okay? Wherever you start from, if you are really into that, you can reach. At the same time, I see some of my students, they come from a quantum computing background, okay? So they have studied this at university, and it's much easier for them to grasp things, to propose things, to come with solution to problems. With respect to people that have that had to learn, a little bit at a time, step by step, because the students have some sort of, how should I say, they have learned in a organized, structured way, the basics. And again, I'm getting back to that. So the thing for me is, yes, of course you can do that. Even if you didn't study these kind of things at the beginning, you can always learn, because I think any of us is able to learn whatever they decide to learn, but you need to invest in that, in the sense that otherwise you are never going to be as effective as you could be. Quantum computing, again, from an algorithmic perspective, to be really effective requires a very different mindset with respect to solving a problem with the classical algorithms. Okay, so this is something that we need to learn. And it's a switch that needs to happen in order to have good results.
Thank you, Sophia. I completely agree that now the people that are starting, that want to pursue now a career in quantum, it's a bit easier for them in the sense that there are some quantum programs, right, in which all these basic concepts are well organized, or we try to
they're natural, they become natural for them.
Yeah, exactly. But at the time that we were studying, the word quantum was hardly there, right? So we didn't have the opportunity or the chance to have this kind of education, of training, right? And therefore for us it's maybe a bit harder to come into it, but it was not impossible, right?
No,
here we are.
Not at all, exactly.
So we manage.
Yes, we manage.
So let me please give the floor then to Marta, please go ahead.
Yeah, I'm actually maybe a bit of a life example of this that you were discussing. In my case, my bachelor's, where I studied engineering, physics, and also mathematics in an interdisciplinary center in Barcelona, which is called the CEFIS, in the Technical University. And of course, that was very general, but I think that in general for everyone at the start of the university, you have to have, as Sophia was saying, very good foundation on everything a bit. And then what I did was I came to the TU Delft, from which where they have a master's program of 2 years, which is much more focused on, well, it's about applied physics in general, but there you can follow a specialization track, which goes into a lot of aspects of quantum computing. So there are a few different courses here in this master, offered actually taught by researchers in QTech, in the research center where I work. And it's actually very, they explain the fundamentals in a very structured way, and also with a big emphasis on the current research that is being done. So there are some courses on fundamentals of quantum information, also quantum algorithms, quantum communication, but that there are also some on quantum hardware, for example, in which you learn a lot about the current research that is being done now in qubits. So this sort of path is, I mean, at least it worked quite well for myself, because it's very hard to already study the more complicated and specialized aspects of quantum computing from the beginning. So I think it's worked out quite well for myself and the people who studied together with me. I know there are also, for example, similar masters. There's one in the ETH in Switzerland, which is also very good on, and very well structured, explaining all sorts of aspects of quantum computing. So this is, I mean, I had the chance now, because at this point, there was already this opportunity of studying a more specialized master's. And I think this is what I would recommend. At least it worked out very well for me. First, do some more generic undergrad studies on physics or mathematics or computer science. And then there are a few different masters that really help getting a good structured view of different aspects of quantum computing.
Okay, thank you very much, Marta, for having shared your experience with us. There are just a few minutes left, so I will just give the opportunity to the audience, to ask some questions. So please, if you have any question that you would like, or any comment that you would like to share with the rest of the panelists and the audience, please unmute yourself and ask the question. Thank you.
If I may.
Sure, go ahead.
Good afternoon. Good afternoon again. I have to admit very humbly that this is the first time that I start with a subjective reflection. I also have a daughter in high school, and of course I only care that she will pursue a career in whichever field she finds a vocation. Quantum computing might be cool, but I don't really care about the topic. Whenever we outreach to people who are in school and high school, the cliche is, oh, I want to become an astronaut. I think that we have on Earth something which is more marvelous than a spacecraft, which is a quantum computer. That combination of technologies, I think that we need to start to use quantum computers to enlighten young people. So my reflection is the following. Marta talked about interdisciplinarity. So you need to assume that you won't be able to be an expert in all fields, but at least you need to be expert in, at the very least, 2 fields. And as you said, you're a living example of that. Is that a challenge in the sense that the learning curve will be longer? Not just because the topic is more difficult or more profound, but you need to be quasi-expert in 2 fields. So that's one question. And then Sophia talked about multidisciplinarity, which is a different thing. You have a group of people working with multiple technologies concurring in a complex system. So then my question is, should we revisit the way we do research? Is it perhaps better that we co-supervise PhD thesis or two PhD students work in a tandem for interdisciplinarity reasons? Should we approach research as a cohort of students that work together? I don't know. It is a question I'm posing to the panelists, and I don't dare to think whether there's a gender perspective on that. I don't dare to ask, but I wonder.
So, Marta, I don't know if you, I'll just say a few words. I'm also not sure whether there is a gender aspect to that, honestly. I can say that research does happen this way, in a multidisciplinary way. We have students that work, groups of students that work together on different aspects of a similar project. I think we always try to encourage that for different reasons. Well, for the efficiency, so to achieve indeed better results, but also to teach them in working, to teach them to work this way, because this is the way you're supposed to do research today. And so this is something that for sure, I think, I mean, it's my opinion, but I really feel strong about this opinion. This is the way things should happen. And of course, this is possible also because we can have then also different expertise at the level of supervisors, okay? Nowadays, students are not anymore followed by a single professor, right, or a single researcher. They tend to also interact with a team. And this is something we live every day. So I think it's definitely the way to go.
Yeah, I totally agree with that. And about your other question about the long learning curve, I also agree with your interpretation, Eduard, that yeah, it's really something that takes quite some time to become knowledgeable about the different aspects of quantum computing. And I think it's indeed a very long learning curve. But that
is it frustrating, or is it frustrating? That's the question. Or I think it will be less frustrating if you know upfront. It will be longer, right?
I think it's frustrating. I mean, it wasn't for me, definitely. I think it could become frustrating if you have like your only goal is becoming an expert in quantum computing. Then you really have to learn a lot of math and fundamental physics on the way. So I would recommend taking it more as I want to learn cool math and cool physics, and that's afterwards. So if you have like intermediate goals, because it's very hard to just suddenly learn all the more advanced aspects of it, more advanced research-wise. So I would really encourage people to take it as a fun path, the one of learning all these pre-requirements that you need, because it's going to take a while. Indeed, it's like something that's quite specialized. But I think that people often really enjoy also learning about basic quantum physics and mathematics. So, I mean, at least people who work in these fields. So I think it doesn't have to be frustrating at all. It's just starting with a mindset of, I'm going to have to learn very fundamental things. But that can be very interesting. So I think it can be a very nice opportunity to learn these things, thinking, oh, they're actually going to be useful also. So it's a win-win. So that's what I think. But it definitely takes some time. So that's something that one has to keep in mind for sure. And about the gender perspective, it's very hard to know and to relate it to, to know how differently you would recommend and how differently.
In the only sense, in the very humble sense, this is a very humble reflection that we come from a past where hitherto research was very individual-centric. And I wonder whether this idea of cohort, co-sharing, developing together the research, working in tandems and things, whether there's a perspective in general. I don't really know, but I wonder.
Yeah, sorry, Marta, go ahead.
No, you can go ahead. Sorry.
Well, I think it really depends on the field, because working in team is something that has always happened in our world, for example, right? CERN was built like that. High energy physics are big experiments, big collaborations. We're talking about thousands of people that work together, different levels of together, but still you are always interacting with others all the time. So I think there are certain fields in which this is natural. I agree with you, it's not the case all the time, but it's an effort that can be made, especially with the new generation.
Very clear, very strong. Thank you.
Thank you very much. We are already a little bit over time, but I think we can take another question from the audience if there is some. No?
Oh, I see that there's a question in chat for me.
Okay. Oh, yes.
Yes. Yeah.
Yes.
Yeah,
okay.
Yeah.
Let me read it aloud. So share about internship, higher education, and job opportunities in quantum space. And this question is for Nithiastri.
Excellent. So I think the first step that you can do now when you want to explore the opportunities that are there, I think, is to register with She Quantum. It's completely free, and we guide you on the upcoming research opportunities, PhD positions, or be it master's degrees, in collaboration with our partner universities. So please be watching the space, and I think that answers your question. But I would more so, it depends on your interest to explore, go out there, search up the kind of programs that suit you, and at your level, which is, if you're an undergraduate student, you probably would want to do internships, and if you are a master's student, you'll be looking for PhD opportunities. So it definitely could be a little bit challenging to find the right program for you. So that's why we are there to help. So please, again, I would say reach out to She Quantum. Thank you.
Thank you, Nithiastri. I see that Isabel Pedraza is requesting to ask a question. Maybe this is the last one that we can take. Please go ahead.
Thank you. Thank you so much. Just one question. I see that is She Quantum. Is it just like for girls? I mean, for women, or guys also can subscribe to She Quantum?
I think that's a very important and interesting question. I would say, like I mentioned in my talk, She Quantum has the word he in it as well. So we are aiming for a global audience. We would like to simplify quantum computing education for a global audience, but the main aim would be to bring in more women into this field, because as a woman myself, I feel that there aren't enough of us who are being given opportunities. There are a lot of people, especially in India, I feel girls are very, very interested in joining this field, but the opportunities are not present, right? So that's why we are, focusing on women more. But yeah, it's definitely, he's also always.
Oh, thank you. I am a professor at the university. I'm just starting with the quantum, and I'm pushing my students to train themselves in quantum. And there are some camps, summer camps to learn quantum computing, and I got a few places for them. But then, and I would love for them to start learning, because it's what they will face in a few years. And I wanted to be sure that I will recommend them to subscribe, and not just, I mean, that all of them are included. I understand.
Oh, absolutely.
I understand that is better to push the girls. I'm pushing all the time. I'm pro pushing women into science. But of course, I'm teaching both. So it's, but of course, I push more girls. I try to push them in confidence. I mean, go ahead, don't be afraid. You know enough to do it. So it's okay. Thank you so much for the clarification.
Thank you, and it's people like you who motivate women. That's the reason why quantum computing is, the women representation of quantum computing is becoming better. So thank you for what you are doing.
Thank you very much. Well, we are way out of time now, so I would like to close this workshop by thanking again the speakers and panelists. Thank you very much. I think all the The talks were extremely of high quality and they were inspiring. Also, the panel, I think, raised a lot of interesting points about quantum computing careers, quantum computing education, and gender perspectives. I think that was our initial goal, and I think many interesting ideas and points were raised by you. Thank you also to all the registered participants. But we have recorded everything and we will make the videos available. So thank you again for your patience and for joining us today. Thank you and see you soon. Bye.
Thank you. Bye.
Thank you.
It was a pleasure.
Bye.
Bye.